Hello guys, today I'm going to explain you how can we solve this problem largest divisible subset. This is the problem from Leetcode's June challenge. Let's read the problem statement. It is said that the given set of distinct positive integers, we need to find the largest subset such that every pair Si, Sj of elements in this subset satisfies the following condition. That means either Si is dividing Sj or Sj is dividing Si. If there are multiple solutions, we need to return any subset that follows this rule. Just keep in mind that subset should be the largest of all the possible ones. For example, here we had 1 2 3, so output is 1 comma 2. Also we could have chosen 1 and 3 as well. Here every number has the same rule that we want, like if we choose all the elements and you choose any two pair, either of them is dividing the other one. So let's say if we choose 2 and 8, 2 is dividing 8, and if we choose 4 and 2, so 4 is divisible by 2. Alright, so let me take this example. Here we have array where we have elements 1 4 3 18 and 54, and we need to find the maximum such subset which follows this rule that any element Si Sj, and they are following this particular rule that either of them is dividing the other one. Alright, so what we can do, we can try to think of generating all the such subsets and see. I mean, that's the naive most approach, that what we can do, we can try to generate all the subset and find the largest one which satisfies this rule. So there can be as many as 2 raised to the power n subset, which is going to time out for the bigger arrays. What else we can do? Because we know that all this such subset should have an element, so basically let's try to think in this way. If one is available in our subset, then let's not take one, because one is dividing each and every element. So let's say, yeah, even if we take one in our subset, what will happen, the next element that we are going to choose should be dividing should be divisible by 1, or either it's dividing 1. So for example, if we pick 4, let's check for 1 what happens when we pick 4. Can we take it? Yes, because 4 is divisible by 1, so we can take 4 into our subset. What else? Now we go ahead and see if 3 can be taken in this subset where 1 and 4 already exist. So 3 could be divisible by 1, but when we talk about 4 and 3, it is not possible, because neither 4 is dividing 3 nor 3 is dividing 4. So we say that 3 can't be included in this one. So the next one which we'll take is we'll see whether let's consider 18. So 18 is divisible by 1, but 18 is not divisible by 4, so we cannot pick this one. Then we pick 54 as well, and for the same reason 54 also doesn't work. So if we pick 4, we saw that the maximum subset that the maximum size subset that we can generate is this one only. Now let's talk about the other case, like when we saw 4 was divisible, and after once we pick 1, can we pick 3 instead of 4, like not picking 4, and let's see once we pick 3 what happens. So now that we have picked 3, can we pick 18 as well? Let's try to divide 18 and see. So yes, 3 is dividing 18, so we can pick 18 also. Now can we pick 54? So 3 is dividing 54, and yes, we can pick 54 as well. But how can we efficiently do this? So because what are we going to say? We checked for 18. What did we do? We checked for 3 as well as for 1. If it is not going to divide or getting divided by any of these elements before this particular point, then it is not going to be included into our set. But for 54 also we had to check for all the elements, like 18 3 and 1. So how can we optimize this? Let's talk about that. So for 18, when we included 18 into our subset, when we had 1 and 3, we will have to check for all the elements before this. So for 18, 3 and 1, and similarly for 54, when we pick 54, we will have to check whether all the elements before this is dividing it or not, or at least one of them is dividing, or 54 is dividing one of them. So this is a part where we need to do a key observation here, is that why do we need to check for all the elements? Because there might be some element, let's say if we had some other element here, for example in this case we could have had 6 as well. So if 6 was here, 6 is dividing 54, so 6 could have also been an answer. But for example if 36 was here, so 36 is divisible by all of them, 6, 1, 3 and 18, but neither 36 divide 54 nor 54 is dividing 36. So in this case including 54 wouldn't be possible. So now it is clear that why do we need to traverse all the way back till the first element to see if all the elements which are included in the subset till now are either dividing 54 or one of them is divisible by 54. I mean all of them are divisible by 54. So how else can we optimize? So we saw that these all the cases only occur when this order that we pick is totally random, like they are not in sorted order. What if this information was given to us in increasing order? Let's say 1, 3, 4, and then we had 6, and then we have 36, then we had 18 here as well. So if we had 18, then we have 36, and then we have 54. All right, so in this case if we are going to say that can we pick 1, 3, let's say for example we are only talking about this subset that we were generating. So we had 1, 3, and we are going to check for 6. So we will only check for previous one, whether 6 is divisible by the previous element that was included into subset or not. If it is included, that means for sure it will be included by all of them here, it will be divisible by all of them is here, because we have been choosing the elements in such a way that the next element that we choose is always going to be divisible by the last element that we had chosen. And so for example 6 was divisible by 3, so let's say if we are going to pick 18, and we will just need to check whether 6 is dividing 18 or not. So now here you can see 6 is dividing 18, and we know for sure that all the elements before 6 are dividing 6 as well, so they will have to divide 18 as well. So we could pick 18 as well. Now let's talk about 36. So because 36 is divisible by 18, and so all the other elements will also be dividing 36. So without checking for all the elements before this, we can just simply say that 36 can be included into subset. Now can this also be possible for 54? Here we can see that 36 is not dividing 54, so for sure we are not going to include 54 into our subset. I mean at least in this particular subset that we are going to generate. So 54 is not possible here because 36 is not dividing the 54, nor 54 is dividing 36, so this is not possible, and hence the largest subset that we could form is this one. All right, yeah, and similarly let's talk about the case when we could have picked 1 and 4, and if we have picked 4, can we pick 36? Yes, if we cannot pick 6. Can we pick 18? We cannot pick 18 as well, because neither 6 nor 18 both of them are not divisible by 4. Can we pick 36? Yes, because it is divisible by 4. And can we pick 54? No, we can't pick 54. So if we include 1 and 4, we can the maximum that we can generate is this one only. Similarly, we could have just picked 1 and 6, and then we can just go ahead with 1, 6, 18, 36, 54, but we can see that there is a better answer than that. So this is the way we can start generating our subset.
So now that we have seen that sorting this array can give a very well optimization on time, so what should be our general approach? So let's talk about that. So the first thing that we are going to do with the input array is to sort it, and then what are we going to do is, let's say what we can say with our problem is the what will be the maximum such subset if we start from the ith index. Like if this particular element, let's say in this case, if in our example, what will be our answer is what is the biggest size if we start from 0, that the first element in the subarray is 0th element. And then we can also try for first element, if what will be the answer if the first index that is in our subset is this 4. So why I'm saying so, because when we picked up an element, then only we are going to find the next potential element. So for example, if we pick 4, if we pick 4, what are all the next possible candidates are basically only 36. So because if we start from 4, what happens there is 36 is the only next element that can be picked into this subset. However, if we start from 3, so what is the next possible candidates that we can pick? So next possible ones are 6, we can pick 18 as well, and we can pick 36, and so we can also pick 54. So these are all the possible ones, and what are we going to do is we are going to pick each of them one by one and find the answer for these subproblems separately or recursively. Similarly, for 1, all of them are the correct potential candidates, so we can try recursively find the answer for all of them. So here is what we are going to do. We will, for each I, we are going to find all the elements ahead of it which are divisible by this particular element, and then we are going to recursively solve the answer for these elements. So for each j, we are going to recursively call and compare the answer. Whichever gives us the best answer would be our maximum size of the subset. So now that we have seen that how can we find the answer, the maximum size of the such subset, now let's try to think also how can we build that subset. So if we take a look here, what we were doing is we were comparing our answer for each of its following next elements. Like for each I, we are finding all the next all the elements which are ahead of I, and also those elements are divisible by the array of I. Then we are going to compare all such j, like all such j in the right hand side of the I, and compare the best one out of it. So if we know that any particular element, so for example for 1 there were all of them were divisible by 1, so why did we only choose 3? Because 3 is going to give us the biggest answer. If we start from 3, we will get 18 and 54 as well. If we start from 4, we will not get any other, and if we start from 18, we will get only 2, and if we start from 54, we will only get 54. So we saw that the next element that we are going to pick is 3, and this gives us the hint that if we somehow maintain this particular thing, like for each element what's the next element that we have picked up, then we are going to find our answer. So because we saw that the best answer is coming from 1, the next thing that we are going to find is that what's the best next answer that we are going to find. So we saw that the best next of 1 is 3, so we can also store like what's the next of I that we are going to choose. So next of I should be the j which is going to divide and gives us the best answer. So we are going to also add this particular check into our array, that if this is divisible and if the answer coming from this j is greater than all the other j that we have found till now, then the next of I should be changed to this particular j which is giving us the best answer. So now let's try to see how we can implement this, and I hope that implementation will also further clear all the doubts that we have. Alright, so yeah, I have declared two variables so that I don't have to pass them every time into the function that I am going to build, and I said that I'll need an index, and if this index already has reached the end of the elements or end of the array, then means we don't have any more element left, so there is no more I mean the biggest length would be 0, and otherwise we say that we are going to maintain an answer, and we are going to traverse all the elements starting from starting ahead of the current element, that is idx plus 1, and ending at I, and we will check for each of them. That means if array of I is divisible by array of idx, then we have found a potential candidate, and we are going to find the answer for this one. So we say that we will find an answer. Let's say we find the answer for this one, which would be 1 plus, because 1 is because we are including this particular I, 1 plus all the answer starting from I, and we check if this A is greater than the answer that we have found till now. What will happen in that case? We said also that we are going to maintain next element that we can next best that we can have starting from each I. So let's just keep it for example 10 raised to the power 4, I would say. Yeah, so we can just update this next of I to be next of idx to be this particular I. All right, because the next best element, if we consider idx into our subset, should be this particular I, because we have seen we have found a better answer for this one. So next of idx should be updated to next of idx should be updated to I, and also we need to update our answer so that we can compare correctly for the next ones, and we are going to return our answer here. All right, so and from this function we are going to try out for all the elements. Let's say, because we said that we can consider each of the element as the first index, so we'll start from 0 till n, and similarly here also we need to keep track of the maximum length that we have till now, and an index. Why do we need index? Let's talk about that later. So we will check the answer starting from this one. So if let's just also keep this one the current length that we found. If we start from this index 1 plus I, if this L is greater than the current length, the global length that we have found, then for sure we are going to change length to be L, and we said that we are going to also maintain a index. So we need to maintain an index which will be our starting index. So this index should be changed to the current I, and yeah, this will be our answer. So we have found the maximum length, and we have found the starting index of the that maximum subset. So what we can do is we can just traverse our maximum subset. What we can do is we can also keep a vector of answer, the result that we are going to return back, and we are going to push back this particular element that we have found. So this would be the starting index that we have just found, which is idx, and we are going to insert idx into our element, into our result array, and then this idx should be changed to the next of idx. That is the next answer for this next element ahead of idx, which would be our best answer. So this should be returned. And also we can see that this particular problem here is basically a dynamic programming problem, because we can see because we are able to divide it into sub problems, and if we draw a decision tree, we can see that there will be these sub problems are overlapping. So we can also keep a dp table, dp array, and we'll see if dp of idx is not already seen. We will initialize in a moment, then we'll just return our answer. Otherwise we will calculate our dp, and then we are going to return our answer and store this answer into our dp. And here we can just initialize our dp by -1 for all the elements. I hope, yeah, this works, because I have already solved this one. I just want to see this works without any compilation error. Yeah, let me just quickly fix this one. So I fixed this one because this was semicolon, it should be colon. And one more thing that we were missing is we need, as we said, we need to sort our array, because otherwise we won't be sure until we traverse back and find and check for each element that we have picked up till now. So instead of doing that, we saw that by sorting we can optimize it. So let's now try to see if it works. Yeah, it works. So let me just submit. Alright, so it's accepted. So yeah, the code is a bit lengthier, but I hope it's very clear. And if there is anything that you want to ask me, please let me know in the comment section below, or if there is any feedback from me or any suggestion, leave that as well. And yeah, thanks for watching this video, guys.